Welcome to my presentation. This presentation is part of the playlist, The Quadratic Formula. In this presentation, we will be solving problems using the quadratic formula. Let's look at an example. Let's say we have a quadratic equation of the form x squared minus 4x minus 7 is equal to 0. We want to solve this using the quadratic formula. First of all, we want to see whether the given equation is in the standard form of a quadratic equation. Yes, it is. As you can see, it is in the form ax squared plus bx plus c is equal to 0, where a is equal to 1, b is equal to -4, and c is equal to -7. Once we have identified the values of a, b, and c, we can then plug them into this quadratic formula, which is stating as follows: x equals to minus b plus or minus the square root of b squared minus 4ac, the whole thing divided by 2a. This formula is requiring three things. It requires the value of a, b, and c. Okay. Now, once we have identified the values of a, b, and c, we're going to substitute those values into the formula. Let us start substituting them. The formula comes with a negative sign. Minus of the value of b is -4, minus of -4, plus or minus the square root of b squared. The value of b is -4, the whole raised to the power of 2, minus 4 times a times c. The value of a is 1, the value of c is -7, the whole thing divided by 2 times a. The value of a is 1. We have successfully substituted the values. Now let us simplify it. So negative of -4 is +4, plus or minus the square root of -4 raised to the power of 2. Negative raised to the power of 2 is positive. 4 raised to the power of 2 is 4 times 4, which is 16. And then here we have -4 times 1 times -7. Negative times negative is a positive. 7 times 4 is 28, divided by 2 times 1 is 2. So now we'll simplify it some more. 4 plus or minus the square root of 16 plus 28 is 44. 4 plus or minus the square root of 44, the whole thing divided by 2. Now, 44 is not a perfect square. So the way we can write it is as follows. 4 plus or minus the square root of 4 times 11 divided by 2. 4 is a perfect square. We can take it outside of the radical term as shown here. 4 plus or minus 2 times square root of 11 divided by 2. Square root of 11 is not a perfect square. Therefore, we're going to leave it under the radical term. So therefore, we can write this as 4 divided by 2 plus or minus 2 square root of 11 divided by 2, like that. Now, 4 is a multiple of 2, so therefore it simplifies to 2. And then the 2 in the numerator, 2 in the denominator cancels out, leaving us with square root of 11. So therefore, we have an answer, x equals to 2 plus or minus square root of 11. The two answers for this quadratic equation are x equals to 2 plus square root of 11, or x is equal to 2 minus the square root of 11. These are the two solutions. Now, these two solutions should satisfy the given equation. So let us check and see whether when we substitute each one of these answers into the given equation, whether they satisfy the left-hand side and the right-hand side. Let's start with x equals to 2 plus square root of 11. So the given equation we have is x squared minus 4x minus 7 is equal to 0. Wherever we see x, we're going to substitute the value of 2 plus square root of 11. 2 plus square root of 11, the whole raised to the power of 2, minus 4 times the value of x is 2 plus square root of 11, minus 7 is equal to 0. So now we can simplify this. The first part here, 2 plus square root of 11, the whole thing raised to the power of 2, is in that standard form a plus b, the whole squared. So the first term raised to the power of 2, which is that, plus 2 times a times b, 2 times the first term times the second term, 2 times 2 times the square root of 11, plus the second term raised to the power of 2. So we have expanded it, minus, there we're going to distribute this 4 to every one of the terms inside the parentheses. 4 times 2 is that, 4 times square root of 11 is that, minus 7 is equal to 0. 2 squared is 4, plus 2 times 2 is 4, square root of 11, plus the square root of 11, the whole raised to the power of 2 is 11, minus 4 times 2 is 8, and then we have negative 4 times the square root of 11 is 4 square root of 11 minus 7 equals to 0. Now we're going to simplify this some more. We have a plus square root of 11 minus square root of 11. These two cancels out. So we have 4 plus 11 is 15, and then we also have negative 8 plus negative 7, which is equal to 15. So therefore, when we add all of those things up, we have an answer equal to 0. Therefore, that is exactly equal to what we have on the right hand side, which is equal to 0. So therefore, the value of x equals to 2 plus square root of 11 is a true solution for the given equation. So let us see whether the second solution also satisfies the given equation. The second solution we have is x equals to 2 minus square root of 11. We're going to substitute that into the given equation. The given equation is x squared minus 4x minus 7 is equal to 0. Wherever we see x, we're going to substitute 2 minus square root of 11, like that. 2 minus square root of 11, the whole raised to the power of 2, minus 4 times 2 minus square root of 11, minus 7 is equal to 0. So again here, when we have two terms like this, 2 minus square root of 11, the whole raised to the power of 2, the first term raised to the power of 2 is 2 to the power of 2 minus 2 times the first term times the second term, 2 times 2 times the square root of 11, plus the second term raised to the power of 2, minus 4 times, we're going to distribute this 4 to every one of the terms inside the parentheses. Negative 4 times 2, negative 4 times 2, negative times negative is a positive, 4 times square root of 11 is 4 square root of 11, minus 7 equals to 0. So 2 squared is 4, minus 2 times 2 is 4 square root of 11, plus square root of 11, the whole raised to the power of 2 is 11, minus 4 times 2 is 8, and then we have 4 square root of 11 is 4 square root of 11, minus 7 equals to 0. Now we're going to put all of these things together. So we have 4 plus 11 is 15, negative 8 plus negative 7 is negative 15. We have a negative square root of 11 plus square root of 11, and that should be equal to 0. So as you can see, plus 15 minus 15 cancels out, minus 4 square root of 11 plus square root of 11 cancels out, leaving us with 0. So therefore, the left-hand side is exactly equal to the right-hand side, and therefore, the value of x equals to 2 minus square root of 11 is true solution for the given equation. So therefore, there will always be two solutions when we solve a quadratic equation. Let's look at another example. Let's say we have an example of this kind, and a quadratic equation which is of the form x squared plus 3x minus 27 equals to 0. This is in the standard form of a quadratic equation, ax squared plus bx plus c equals to 0. We can we want to identify the values of a, b, and c. Once we have identified them, we're going to substitute that into this quadratic formula, which is x equals to minus b plus or minus the square root of b squared minus 4ac, the whole thing divided by 2a. Okay, let us see what the values of a, b, and c are for our particular problem. Step number 1. The value of a is 1, the coefficient of x squared is 1, the value of b is 3, and the value of c is negative 27. We have identified the values of a, b, and c. Now we're going to substitute these values into the formula, that is in our step 2. So the formula is negative b. Negative of the value of b is 3 plus or minus the square root of b squared. The value of b we have is 3 raised to the power of 2, minus 4ac, 4 times the value of a is 1, and the value of c is negative 27, divided by 2 times the value of a is 1, like that. We have substituted the values of a, b, and c into the formula. Now we need to simplify. As step 3, we're going to simplify. Negative of 3 is negative 3 plus or minus 3 raised to the power of 2 is 9, and then we want to simplify negative 4 times 1 times negative 27. Negative times negative is a positive. 4 times 1 is 4. 4 times 27 is 108 divided by 2 times 1 is 2. Now let's simplify it some more. Negative 3 plus or minus the square root of 9 plus 108 is 117, the whole thing divided by 2. So now we can simplify it some more. X equals to negative 3 plus or minus square root of 117 is not a perfect square. So we want to see whether there are two numbers where one of them is a perfect square. So if it is a perfect square, we can bring it outside of the radical term. Now we know that 9 times 13 is 117. So 9 is a perfect square. So therefore, whenever we have a perfect square under a radical term, it comes out as its base number, as we have written it down here. X equals to minus 3 plus or minus square root of 9 is 3, square root of 13. 13 is not a perfect square, therefore we're going to leave it as is under the radical term, the whole thing divided by 2. So therefore we have two solutions. The first solution is x equals to negative 3 plus 3 square root of 13 divided by 2, or x equals to negative 3 minus 3 square root of 13 divided by 2. So sometimes we may have solutions as whole numbers, and sometimes we may encounter radical terms, which is perfectly okay. Both these solutions satisfy the given equation. They will, as a note, I want to mention here, there will be two solutions whenever we solve a quadratic equation. In my next video presentation, we will be solving more problems using the quadratic formula.